Make sure you guys join the Discord if you have not. Make sure you guys sign in as well. We'll be checking with pizza. Make sure you sign in. Make sure you guys check the calendar. RIT Tech mailing list as well. Now, guys, clap it up for the sponsors. All right, thank you. Make sure you follow our social media. All right, now for announcements. Did you guys do a call up this summer? Make sure to scan this QR code. We might have one coming out about next summer as well. Make sure you guys sign up for ISTS Black Team. The competition's from February 28th to March 1st. Sign-ups close on November 26th. Yes, Leah? All right, wait. All right, February 27th through March 1st. Blue team signups are not happening yet, but if you want to, actually no, there's no blue team signups. I'm sorry, but white team signups will be posted later, and you can sign up for black team now if you still want to be involved. There's more information with this other little QR code right here. Now the WESIS last call for challenge authors. If you guys want to make your own challenge for the CTF, scan this QR code here, and they're due on November 10th at midnight. You can compete online or on campus from November 14th to the 16th at 5 o'clock to 5. Also, there's junior tech lead applications are open. If you guys want to be the next tech lead, sign up to be the junior tech lead. And you'll attend the general meetings and set up the demos. And it's a good experience to have. And yeah, if you have any questions, don't be afraid to reach out. Also, OT Security Interest Group has a guest speaker from Avangrid, Christopher Cotter. He's talking November 18th from 5 to 6 at the Air Gap Cyber 2750, so make sure to check that one out. And now we have Intro to Black Team by Leah. How was IRSec? Was it good? Yep. Everyone liked IRSec? That's all right. Oh, yeah? Oh, that's cool. Alternate presenter here.
I learned that there's obviously no way to do speaker notes.
Oh, there was a way, but
No, there's no
it's
way.
difficult. It's difficult.
Okay, ready? If we do the, okay, let's not have my Slack on there. And then presenter view. And then bring this over here. And then if I do like, yeah, that works well.
Want to make it bigger?
No, I'm not. That's okay. I think I did. Leah cybersecurity. This is from like an
You got
open
the
house.
cybersecurity on there, too.
It's because there's like an open house, guys. Okay. It's like a accepted students thing. Oh, no, please. Please, presenter view. How'd I gain?
Cool.
I start? Yep. Okay, cool. Yo. Hello, everyone. We ready to learn about Black Team? I'm Leah. We're going to talk about Black Team today. So, who am I? I am Leah Kvares. I am a third-year cybersecurity major. I'm also minoring in MIS and music performance. I am your current ISTS competition architect. As Adam just announced, Black Team signups are open for ISTS, so if you're interested in that, if you already signed up, you can learn more. If you haven't signed up, I'm going to tell you all about it, so we're going to have like the most goated Black Team of all time this year. I was the head of education last year for RITSEC. I'm on the CCDC team. I've been on Black Team since like the first time it was possible for me to be on it, and I've been on it for the whole time. My credentials to give this presentation, I guess, is like spring semester 2024, I was on ISTS Infra, then I was on IRSEC Infra that same year in the fall, then I was Infra lead for last ISTS, and then I was on Infra for this past IRSEC. And I guess, yeah, I'm a CA. What else? I'm on Red Team. I was the first ever Slidely Cup winner, guys. If you don't know what that means, we have Slide Roulette coming up. You'll hear more about that probably from Adam, but that's pretty cool. And I do a lot of performing arts stuff. Audience participation. Can you guys raise your hand if you know who Dan Povenmire is? Okay. Can you raise your hand if you know who John Hammond is? Okay, that's it. Garrett's not here, but pretend that everyone knew who John Hammond was. I met him right there. All right. I'm not changing slides. So what are we going to talk about today? First of all, we're going to go over the competition types, then the Black Team organization for each of the competitions, and then we'll talk about Terraform and Ansible, which are the things that we use to put up these competitions. Competition types. So, red versus blue competitions. You guys probably have heard a lot about these because that is what IRSEC was. IRSEC stands for Incident Response Security Competition, and it is a great example of red versus blue. So if you were a first year or just if you signed up for IRSEC, it is our beginner-friendly red versus blue competition. And the way that we operate with these is obviously you guys had like PCs in front of you, and then you would remote into virtual machines that we had set up in our virtual environment, which is OpenStack. The theme and the environment change every single competition, so that means that, for example, this past competition was time travel themed. Last year's was fictional Cold War. The year before that was casino. I was about to say gambling. Casino, same thing. So it's always something really fun and creative. I think a lot of people consider the decorations of the room when they pick out their theme, but then also everything in the competition is shaped to the theme. So like the box names, the roles of like what you are as the blue team, what the red team is, like fictionally, all of that changes. And then the environment, meaning the types of VMs that are in it. So for example, we had Windows 10 for like a lot of Windows Server 22, I think, very specific operating systems, Ubuntu 2204, etc. So the blue team's role in these competitions is to defend, as you probably know. The blue teams are teams of 5 in IRSEC and ISTS. And what they do is red team pre-bakes, which means that they get access to the virtual machines before you. And they put their malware on the machines, they put their implants, they hide everything really well, and then they make sure that they're getting callbacks to their C2s, back to every tool that they have, so that we have I'm on red team, but so that red team has persistence to all the hosts, so that you, in turn, as the blue team, go in, find evidence of malware on the system, whether that is files, whether that's traffic, and then sometimes you have to talk about it in injects. Sometimes at the end of IRSEC, for example, there's an incident response report, which you all wrote. And yeah, this is all meant to be an educational experience for you to understand, like get familiar with operating systems, get familiar with what looks normal on a system. That's really important. And yeah, kind of get better at threat hunting, incident response, that kind of thing. And this graphic I created, it means that red versus blue competitions are the bread and butter of RITSEC. Yeah. And yeah, examples of red versus blue competitions, I just like heavily lean on IRSEC as an example because it was really recent. ISTS, which I will talk about more, is another, has a red versus blue component, but not necessarily the main focus of ISTS. And then things like UB Lockdown, which is University of Buffalo's, like NetDef is their cybersecurity club, their competition that a lot of RIT students like to go to. And then the Collegiate Cyber Defense Competition is also a red versus blue competition. The next type of competition is a CTF, which stands for Capture the Flag. I guess you could describe it as a Jeopardy-style competition. This is more of like, there's no like live traffic from a red team or anything like that. This is standalone challenges that people build, and then you go in and solve them. So there's different categories, which is why there's like a little Jeopardy graphic. The most common categories are stuff like web, pwn, crypto. OSINT is a fun one, and then Fortnite item shop. I don't know. I didn't make that. I just kept it from the last presentation. And examples of this are, for example, the upcoming WESIS CTF from our WESIS chapter, the RITSEC CTF, which happens in the spring, and then Seesaw, which also is happening like right now, I think. So yeah, CTFs are more like the general, how I see it is a lot of other cybersecurity clubs at other schools focus just on CTFs. But then, like I was talking about, like red versus blue is our bread and butter. So there's different kind of like angles that you can go at with gamifying cybersecurity education. And CTFs are a little bit more widespread because they're a little bit easier to put up with things like CTFD. Then there is something called KOTH, which stands for King of the Hill. So this picture, I think I literally took it from Hack the Box or Try Hack Me, because these platforms are the kinds that use like this format of learning. What KOTH is that there's multiple or standalone hosts that have built-in vulnerabilities. So if you've heard of people like in RVAPT doing Hack the Box, that means that there's some kind of like VM, you know nothing about it, so you have to do reconnaissance on it, right? Like scan it with Nmap. Then you have to figure out what's on it and then go through different attack vectors. So like a really simple example is if port 80 is open, you'd probably try to visit like the web page on that host and then figure out like if there's a web vulnerability, like if it's running WordPress. WordPress is a very common example where you exploit things, and like it's not like custom stuff. You can probably find references online for it, but that's an example of that. If it's like a combination of machines, a big category is like Active Directory exploitation. So understanding the relationships of machines in Active Directory for Windows, and being able to use those to like hop from machine to machine to get DA eventually, domain admin. And for example, in ISTS, we have a whole KOTH component. So other than when in ISTS we have like the blue team sitting in this room fighting off red team, they can also, if things aren't going well, or they often like bring someone specific on the team to focus on KOTH, they can go and sit on like the KOTH network and try to hack into the boxes on there. So this is more of like the offensive, not just like kicking out red team. It's more finding the box, exploiting the vulnerability to get into it, and then claiming it with a token. There's different ways to prove that you actually hacked into it. On Hack the Box, for example, when you like own a box, you just like read a user.txt file or an admin.txt and then submit it. So kind of like a CTF thing. But then in our KOTH, I might explain this wrong. I didn't do KOTH, but we have like KOTH tokens that you put in your own, and then once it's on that system, it's claimed as your team's. So yeah, I think I explained that pretty well. That's the get in, stay out, keep others out. Once you claim it in ISTS, for example, you want to secure the box. So yes, it is a vulnerable host, and you should have found maybe one of multiple vulnerabilities on it, but now you want to like claim it, like keep it on your team. So you want to secure it so that other teams can't claim it. And then I guess I should have put RITSEC competitions first because I've been referencing them a lot, but we'll talk about what makes up the IRSEC black team, for example. I pulled these numbers before IRSEC happened, so they might be a little bit different, but we had about 33 black teamers setting up IRSEC on all of those like black teams within the black team, and then we had 18 white team members run by our white team lead to help set up, which again, I will explain what that is. But yeah, the black teams for IRSEC are pretty simple. We have infra that puts up all the boxes to make them ready for Linux and Windows to deploy to. Linux and Windows, in turn, configure those machines that you would be working on as blue team. So again, like I was talking about in the topology, like if you have Linux boxes, all the users on them, all the custom things like the services, They were put up by people on the Linux black team. Same thing with Windows. Windows has to like disable Defender for our red team. They have to put the users. They have to set the backgrounds. All things that sound really easy, but are not really. Scoring is really important because that's how we like know who's winning. So we use Scorify, which is written by an alumni. And the way that it works is the scoring team has to like put up the minions. They have to put up the scoring server, and then write the score checks. So like a very simple example of a score check. I might be getting ahead of myself because I think this is later in the presentation, but a very simple score check would be just like pinging the box to see if it's up. And if the ping like receives responses, then it's green on the scoreboard. If not, it's red. But we'll talk about that more. Injects are also super important because that's like, you know, when you guys got handed out like pieces of paper during the competition that said like, I don't know, give us an inventory of your infra or something like that. That's created by the Injects team, and they have to work hard to make sure everything makes sense in the theme because, again, we want it to be very immersive. So it's not just like a random inject that doesn't make sense. And then they just have to have a better overall understanding of like what's a reasonable task to ask from a blue team that's kind of busy right now, and also how much time to give them for it. So this, like, injects are, it's a weird word because people put injects on their resume, and then real people like in the industry are like, what is an inject? So I call them business tasks usually, and this helps bridge kind of the idea like, okay, if you were working in an actual company doing instant response, for example, that doesn't mean that your job on the side like stops like what you normally do. So if like your boss needs something, you still need to do it while doing whatever you're busy with currently. So that's what an inject is meant to kind of emulate. Logging, also super important because we want to make sure people aren't breaking rules. So logging sets up Datadog, and they see lots of very cool logs actually from the blue teams. I'm definitely going to explain this later, so I'm just going to keep going. Store, super cool. We have a store, and it's always themed really well. Again, I keep coming back to the theme, but it's really important to the competitions. And the items on there will be named something like having to do with the theme, but then they represent, for example, a revert. So I think in IRSec, reverts were the big bang because it's like, oh, I don't know, something's been created. So if you bought a revert, black team would go in and like revert your box. Let's keep going. ISTS black team is a little bit larger. So if you notice, I kind of kept like the left side the same, and then on the right side it's different. ISTS, alongside all of those teams within black team, also includes a Weird OS team. Weird OS and ISTS is a weird operating system. So this past ISTS, it was Temple OS, which if you don't know, does not have networking natively, but our very smart students managed to make it like networked, which was a very fun challenge for both them and then for red team also to deploy to and for blue team to defend. I don't remember what ISTS Weird OS was during 2024. Nix OS? So that's what that was. Again, like I just talked about, King of the Hill is specific to ISTS, not IRSec. So on that side, the Koth black team are the ones actually creating the boxes, putting them on the Koth network, and then testing them to make sure those vulnerabilities work. Game is, oh, I just skipped CTF, I'm sorry. CTF, we have basically a whole CTF going on while all this other stuff in ISTS is happening. So obviously the CTF team creates the challenges, puts them on CTFD, tests them, all that usual CTF stuff. The game, super fun. The game is, it varies very heavily each year, and we've started leaning more towards like physical security for the game. And it's just something fun, something custom, something for the blue teams to have fun with alongside all of those other components of ISTS. For example, the game this past year, ISTS was bank heist themed, so we got like a giant safe that they had to break into, and there was also like other stuff, like it was like breaking into a bank basically, with like lights and like lasers and other lock picking things. And then the year before it was Wild West themed, so it was a Nerf blaster shootout, also with like picking your teammate out of handcuffs, and stuff like that. So it's something like fun, silly, but it is scored, it's part of your score, and we need a team to be able to, first of all, run the game during the competition, and also plan all those things, see what we need to buy for the game, stuff like that. And then phones is sort of a black team. At this point, it's like one or two people dragged out of a different team, but we do have like phones for each team during ISTS, so they can call each other, they can call red team, stuff like that. When you take network services, you will learn how to set up VoIP, so that's a fun time. And yeah, this is a larger black team of last year, about 52 black team members, which is pretty big. That's a big group. I felt like I needed to mention the RITSEC CTF black team. I was on it once for infra, but it is very different from ISTS and IRSEC. All I can say is it uses OKD, which is more of a Maxim and Joe Abate thing. And then the other teams are QA, quality assurance, and then the actual challenge authors who write the challenges for the RITSEC CTF. I can't really speak to this one too much. I guess we'll talk about the organization more than I did. Oh, okay. So when you think of black team, we got the competition architect. So for example, Ariana Schwartz was the competition architect for IRSEC. And then there were black team leads that report directly to the CA. So for example, Brenner was the store lead. I'm just looking at people. Philip was the scoring lead. Casey was the white team lead. So this means that they would be in direct contact with Ariana for everything, like making sure that her vision of the competition is like they're staying true to the vision and just like doing what the CA wants, because one person cannot single-handedly put up a competition. And then in addition to that, each team has just like black team members. So Brenner would have people that are like, he would hopefully be delegating to and telling them to like, okay, work on this certain feature for the store, or like do this styling or whatever it is. So these people are doing like the hands-on technical things. Not to say that the leads aren't, but the leads need to be understanding the bigger picture as well, so that they can properly delegate those smaller tasks. Yeah, and then we used to have, like it says, okay, this is like weird terminology. This says black team leads. We used to have a black team lead. So pretend that this says like Windows lead, Linux lead, store lead, whatever. We would have a black team lead between the CA and those leads as a sort of like assistant manager to the ISTS CA. Or I don't know why I said ISTS. We did try this in ISTS. And it's a role that some CAs might want, just to help with like all the logistical things, because as the competition architect, you're not really going to worry about like, okay, how am I getting these users on Linux boxes? You're more so worrying about like the teams that are being invited, like make sure that everyone's in the Discord server, make sure that like the theme is going well. Like you gave guidance to the other black teams, but you're not doing the very small details that every team does, because it's not possible. More about the competition architect. Perfect. It is, the competition architect is the big cheese. I promise I did not, like, this was kind of already here on the slide. ChatGPT even knows, guys, ISTSCA is me. It's not me. This is like from when Drew made the presentation. But yeah, the CA is basically a project manager for the competition, like I was just explaining. They don't worry about the very fine details. They worry about making the competition happen. Which includes like interfacing with RIT, the department. I'm going to talk about in terms of ISTS, because this is what I worry about like now until ISTS happens. Again, making sure the teams are all set, that the teams can travel here. For example, if it's ISTS, because we invite other schools here. For IRSEC, it's more like, do the teams like know what's going on, and will they show up the day of? Then the competition architect leads all the leads meetings. So that was like an unfortunate phrasing, but the black team leads, they have usually weekly syncs leading up to the competition to talk about, you know, what's going well, what needs to happen still, making sure that everything is on track to happen. Especially for what we usually do is we have like one long day on a weekend called deploy, which is when we make sure that everything goes green on the scoreboard, and this involves every single black team to make sure that that happens. So yeah, it all lies on the CA, the big cheese. I guess, yeah, I had more about the teams. I just like talked too soon about it, but I asked all the leads like what skills that they think are used for their specific team. So of course, again, for infra, that's what I've been doing for many semesters. We learn Terraform, we learn Ansible, networking, which used to be its own black team, but then basically got absorbed by infra, and then OpenStack, of course, because that is where we host our competitions. the operating systems, meaning Linux and Windows. A lot of them, not a lot of them, they use Ansible, things like scripting, and then OS specific configuration, knowing how to actually set up like domain joined hosts, for example. Scoring, again, Ansible Docker, knowledge of services to write those score checks. Injects, like I mentioned before, understanding cybersecurity just in general so that you can come up with creative inject ideas, just make them fun for the competitors, and also be organized because you need to keep track of who submitted what grade you're giving them on the inject, all of that stuff. And then store is more dev focused than cybersecurity usually is. So they do Git, React, TypeScript, Golang, REST, API, things to make a good website. And then logging didn't respond to me, so I put Datadog. I'm sorry, I don't got much for logging. They also helped out with, I believe they helped out with Waza for IRSec. And then I've got the asterisks on the teams that are appearing in ISTS but not IRSec, which I kind of went through already. So those are all the teams that go into Black Team. Now to talk a little bit more about infra. It didn't change. Okay, that took a long time. Infra is the first Black Team that starts working. They go in because the way OpenStack works, there are different projects. So like if you've been on our RedSec stack, basically you have in the top left corner, there's a little drop down, and then it usually has your student ID, which is what we name your personal project. So like my project is called LK3053 because that's my RIT ID. And then I can like do stuff in that project no one else sees, okay? I put up my VMs, whatever. Infra creates the project called like IRSec 2025 in OpenStack. So if there's no project, like the other teams can't go in and do anything. So that's where Terraform comes in. I think there's gonna be like a whole Terraform section later. So this is as a high level overview. Terraform creates the project. Then Infra uses Terraform to create all the management hosts, which include things like DNS for the competition, because we use our internal DNS, obviously. Time.warp is not a real domain. We put up, what else? I'm just like blanking everything. Like the host for scoring, the host for store, all of those things so that like, oh, I literally have it right there. NTP, the VPNs for Black Team to be able to VPN in. Same thing for Red Team to be able to VPN in and deploy their things. And then Uptime Kuma is a cool little tool to show, it's kind of like a scoreboard, but for our management hosts. So if stuff is not working, you can refer to that once you set it up properly and then see if like, oh, okay, things aren't working because our own DNS is down. So let's fix that first. And yeah, manage hypervisor running competition means OpenStack. And Terraform is an infrastructure as code tool. So I guess additionally, we do the networking. Not so much when it's nothing complicated, like setting up the PCs in this room wasn't too bad. We did have to call in our networking specialist alumni, but the like plugging in the computers into switches into the floor doesn't take too much networking on that side. If it's something weird and interesting, then that's when networking comes in. But yeah, Terraform is kind of like the go in, create the project, create the VMs, and then after that, the other teams like Windows go in and like use Ansible to configure the VMs themselves. So Windows, I don't know who put like versions with a question mark, but they don't, this implies that they decide the versions. They don't, but I guess they deal with the versions that the CA decides. So for example, Windows 11 right now is newer and Windows Server 2025 is newer. So those are things that we haven't seen in competitions yet, but they would be configuring those kind of operating systems. Nothing as old as XP or 95 in the time that I've seen. It's usually Windows 10, but yeah, that's a little screenshot from Connor's Proxmox when we were trying to make a good Windows image with no Defender, which we succeeded in. Thank you, Connor, for your hard work. Yeah, that was like a big task for Windows this time around. And then, yeah, what Windows thinks about as the Black Team is Active Directory, Defender, I've said that many times, putting the users, so like when you saw in the packet, there were local users, there were admin users, they have to make sure those are all good. General Windows tomfoolery. I don't know what goes on in Windows, I'm a Linux person, so good luck, have fun. And then the services that they deploy onto those Windows machines are things like Active Directory, DNS, SMB, WinRM, IIS is a good one, SQL, ICMP, kind of mid, Not gonna lie, not my favorite score check. But these are all services that you usually see on Windows hosts that are being scored. And then we get the Linux guy peeking through because next is Linux. Linux deals with, again, different distributions of Linux. For IRSec, we keep it more familiar, so I believe it was just Ubuntu, Fedora, maybe Rocky in there. And then funny distros like Hannah Montana Linux, Debian. I don't know when this last has been seen, but hopefully ISTS will have some cool distros, those who know. And then Linux does things like install packages, users, dependencies, make sure that services like work. Again, just configuring Linux systems. That's their whole job as Linux. And the services you'd see on Linux are, of course, SSH to get into them, especially the cloud ones, FTP, some kind of site. Again, SQL and ICMP, those also can exist on Linux. Yeah, we got a cool Linux guy with sunglasses. Here's some more about logging. So we do use Datadog. This is probably really difficult. Yeah, that's like really hard to see. You can see when I send out the slides, but there's just like a screenshot that I want to include of like some messed up logs before logging got everything working. This is what a Datadog dashboard looks like, and you'd be able to see usually like actions, especially what we pay attention to is, for example, disabling or deleting or changing the password of a white team user. That will be logged. Deleting a user like is specifically a log that I've seen. If they use antivirus, they being blue teams, because we don't allow that. And then in ISTS, logging is also really, really important because in ISTS we allow purple teaming. And not purple teaming in the usual sense of like collaboration, but purple teaming in the sense that blue teams can red team other blue teams. So if blue teams are attacking other blue teams and we tell them not to do anything too destructive, sometimes they don't listen. And as a result, we need to give them point penalties, and we can have logging kind of check for us, like, okay, when did this happen? Maybe what like sort of connection there was, which user they used, things like that, so we can pinpoint. If it was really a blue team attacking another blue team, or maybe red team doing something, or maybe a blue team teaming themselves, or blue team red teaming themselves, which happens a lot. So logging is really important for visibility into the competition. And yeah, logging also helps out, I think I said this earlier, with using like logging for the competitors. So in IRSec, there was a WASA box. It was out of scope for red team, just there for blue teams to use as a resource, and logging would help with that. All right, scoring. So I mentioned we had a custom scoring engine called Scorify. ScoreStack is listed there because that's what we used to use. Scorify is great. First of all, it includes an inject submission in the app, as you guys saw during IRSec, and it also has Koth scoring built into it for ISTS. So yeah, what you can do within it, this picture on the right is an example of writing a score check from probably last IRSec, if I am understanding the host name. Yeah, Cold Conflict was last IRSec. So this one is doing an LDAP check. No, it's not. What is going on? It says, yeah, it is. It is. Sorry, I read ICMP. So port 389 is where LDAP is, and then it kind of defines the team number as a variable value. So that's the way that we name our hosts. Obviously, it's hostname.team whatever .domain, and then what it's checking for there is that it can just connect with a user and a password. And then what we did try to stress during IRSec is if you're changing passwords, which is something that you should be doing in the competition, you also need to remember to go into Scorify and change them on your end. So I think from a competitor view, Scorify, you can just go into score check and all you see is like change password. So you gotta enter that password that you just changed on the actual system into Scorify. Otherwise, the score check will fail. Same thing with like, if it's an SSH score check, it's very often SSHing in with a certain user. So if the user is called score check and the password is score check, but then you change it to something more secure, which you should, Scorify will start failing the score check because it's trying like the wrong password and it obviously won't work. But yeah, and then the scoring black team also does the final score calculations. They adjust scores if teams got point penalties or if teams got extra points from like winning a foot race or whatever they do out there for different store items. All that is on the scoring team. Injects. Yeah, business requests. I made sure to include that terminology in here. This is an example of an inject from last year. It's always very nicely themed with the competition. So like I said before, I think I'm just repeating myself at this point. Injects, they write all of these injects. They figure out the timing and when they're released, when they're due, and then they create the rubrics because obviously we want to make sure every team is graded fairly on their injects. Then they actually spend time grading those injects with the help of white team because obviously there's lots of teams, not as many white teamers and injects members to grade them. So we have literally like the whole time they're in the back room, usually in the LaChase suite, working hard and grading the injects, and obviously they're the ones handing them out as well. Store. Yeah, guys, I didn't realize I had slides for all these. So I included a little screenshot from the store for my RSEC. It looked super cool. It was a whole timeline because of time travel theme, and it had all the events on there as items. When you buy an item from the store, there's a Discord webhook that goes off and adds like the store team or the people that are in charge of looking at what was purchased, because we're working hard behind the scenes to keep track of what everyone's buying to be able to fulfill those at like a timely manner. And the different items, for example, you can remove a team's chairs, you can take away their mice, you can replace a blue teamer with a red teamer, you can request a box revert, which was very popular. All of these things, again, they're called something silly on the store, but then they're like themed and they fit into something that corresponds with like something that you'd want to happen during the competition. And it allows for the chaos that you see in the competitions, like a team being full of red teamers using their mice, and like no chairs. They're just like kneeling on the floor. Or there's like people being handcuffed together or whatever it is. So we just try to make it a little fun. It is chaotic, but it's part of what makes these competitions a little bit extra interactive. And just so you know, when you're buying reverts, everyone's coming to me behind the scenes and telling me to revert boxes. So it's just one person. It's just like, you know the meme where it's like, this is who you're talking to, and then it's like a little like rat or like a puppy. That's me. And then, I don't know, I just have like a fun screenshot of Lucas in the store from Garrett's laptop, Docker. I don't know. White team lead. These slides change really slow. I don't know why I put the word lead there. Let's just pretend it says white team. The white team are assembled after the black team. So white team signups usually open up a little bit closer to the competition date. And these are just volunteers who set up this room. So they like help us move all the tables. They help us get out all of like the dozens of computers that we have in storage, the monitors, all the cables, keep everything organized while doing it. Keyboards, mice, switches, everything that goes into a whole setup for a team of 5, multiply that times 18. That's white team helping us out doing that. Then the decorations, of course, you know, we have like whatever decorations for the theme of the competition. They go up on the walls, on the tables, they help with that. And then, like I mentioned when I was talking about the injects team, they go during the competition, they help with injects, grading them according to that rubric that they created. And they also are very, very important to communicating between blue team and black team. So the blue teams, they're of course all busy sitting here like fighting off red team. White team should be patrolling the room, looking for people with problems, kind of assess the situation, and then find the best black teamer to help with that problem or help them out themselves, because we try to provide them with enough information, enough context to the competition to troubleshoot the basic issues. So white team are just like the helpers for the competition. We really could not do it without them, which is why I have this meme of like the white team holding up the competition, because yeah, we couldn't do it without them. That's all I have for that one. And then the other teams, it would take a while to go through, so they're all on one slide. Like I explained the game team just like figures out what the game is, all the details, what to buy for the game, where to have it. Like we used to have it in one of the labs upstairs, we had it in the club room upstairs, whatever it is, wherever it is, game is in charge of that. And then they're in charge of making sure that it's like happening during the competition, because it's usually supervised by a black team. CTF, very straightforward. They set up the CTF. They write the challenges for ISTS, and yeah, they just take care of the CTF side of things. Same thing with Koth. They work on the Koth boxes. They make sure that they're all created in a timely manner for the competition, and then they take care of things like Koth reverts or like whatever. If teams are having issues like redeeming their Koth tokens, claiming the boxes, they can probably help them give hints on how to hack the Koth boxes, things like that. That's what the Koth team does. And then WeirdOS sets up a very specific operating system, literally anything. It's usually really cursed. And we have a separate team for a reason because it's something very strange, not often seen, so we need a team dedicated to it. And especially, again, in terms of troubleshooting during the competition for WeirdOS, that is very, very important. Okay, let's talk about Terraform. So, like I mentioned before when I was talking about infra, Terraform is an infrastructure as code tool by HashiCorp. It's used to build, deploy, destroy resources. And then the really cool thing about it is that it's flexible with the HashiCorp language, and then that it's stateful, which means that once you run Terraform, it has a Terraform state file that's kept on where you ran it, and there's like a lot of Terraform state commands, like Terraform state, whatever, that help you understand what is deployed in the environment, and then Terraform ingests all of those details so that even if something very small changes, if you rerun Terraform apply, it will be aware of that and it will change them for you. So something very basic is if I had already deployed a bunch of instances on OpenStack with Terraform, and then I decided that I wanted to change their host names, I could just go into Terraform, change that one line, and then rerun Terraform apply, and it would know to update the instances in place, so it wouldn't destroy them. It would understand everything that is already like created using Terraform, and it would only update the name. So it's things like that that are really useful. Or if, for example, someone accidentally deletes a port on OpenStack, you can just run Terraform refresh so that it like refreshes the state, and then run Terraform apply so that it recreates that port exactly how it needs to be, which was really useful for me during the competition. Usually, I would not be using Terraform during a competition because once Red Team deploys, those instances differ from the ones that are like clean set up by Terraform, right? Because they have none of the configurations ready. They're like snapshots of a different state of that instance. But for example, when I was reverting routers, the ports were just not cooperating with me manually. So I decided to go in, delete the Terraform state, and then reapply it. And it worked. I don't even know what the difference was, but Terraform did it right, and I did it wrong. So that was good. And the way that Terraform works is that there are different providers. So the provider we use is the OpenStack provider, but there are other ones, especially like AWS, super popular one, GCP, Linode, super popular, Domino's. I remember watching this presentation 2 years ago from someone else was giving it, obviously, and they said that you can order Domino's pizza with Terraform. I don't know. I can't elaborate on that. There's something interesting coming up for Terraform, though. So more about what Terraform looks like. So the example on the right, kind of, we're going top to bottom describing what it is. So you need to have a Terraform module defined. So I just said I'm going in order. I'm not going in order. That's bottom. A module is like a common object. So in our Terraform for the competitions, a module would be called like Team LAN or Team Cloud. So within a module, we would have the different instances that go into a team's LAN network. And then, let's see. You need, first of all, information about the project in Terraform, like up top. So that means defining the provider and then the version. The source is like, if you look up Terraform providers, they have really good documentation, and you can define different sorts of sources for like the Linode provider, for example. Or for Proxmox, there are different providers. I struggled to find a good one until I finally just like tried all the different ones, and they differ in the way that they expect you to define the other parts of Terraform. So you just have to kind of read the documentation, play around with what works for you. Yeah, the provider is like the API for interactions. So with the OpenStack provider, for example, on OpenStack, you can download the OpenStack RC file, which has like the project ID and then the credentials that you use to access that project. Because obviously, if you don't have access to a project, you can't do things on it. So the way that we put up our stuff for the competitions is we have that OpenStack RC file downloaded. We actually recently started using an application credential, which is a different thing you can set up in OpenStack so that you don't hard code your credentials on a shared box with like 50 other black teamers. And yeah, that lets you interact with like the OpenStack API for using Terraform. Then variables are more like, let's see if this example has anything good. API token, that's not a great example. In our competition stuff, variables, I believe, are like the competition name and the username, if I remember correctly. Resources are a very important one for OpenStack. So resources are like the infrastructure objects that you create and manage with Terraform. And that is things like the actual instances, maybe the networks, or even things like DNS records. So the resources, they depend on the provider because obviously instance means different things on different cloud providers, for example. It's confusing to use the word provider there, but instance is a different thing on OpenStack than other places, for example. And then, like if there's a provider for AWS, then it has modules for things like S3 buckets, VPCs, like EC2s, things like that. For OpenStack, it would be different. It would have modules for OpenStack native things. You can ask me questions about this later. There's a lot. But really, the Terraform documentation is really, really good. You can even teach yourself all of Terraform with their free, like, open docs, and then you can take, like, their Terraform exam, and it's all, like, solely based on the information they have available for free. Great, I included a specific example. I was right. So variables for our competitions is like the name of the competition. So ICS, for example, the domain for the competition, because you want to define variables separately, so you can just change that one little value in the variables.tf Terraform file, so that, you know, when we start doing the Terraform for the next competition, all I have to do is Command F for IRSec 2025 and replace it with ICS 2026, stuff like that. And then team number, again, it's a very like repetitive thing that will come up in the Terraform. So you want to just define it once as a variable and then be able to dynamically replace it in other places. And then you can see that's the provider that we use for OpenStack. It's called Terraform Provider OpenStack. And then for the provider, we define those project names. So let me try to explain this. So for the OpenStack provider, what I was saying is when it expects those specific things, this specific OpenStack provider, it expects a tenant name, username, password, and auth URL. So that's what it knows. And then when we provide it, what tenant name actually means is the project name. So what I was talking about, my personal LK3053 project, or like the IRSec 2025 project, that's where that goes. And var.project name, again, relates to those variables defined in variables.terraform file. It would literally just be a string that says IRSec 2025. And then it's dynamically loaded into the provider. And then everything else, again, for that username, password, the auth URL is like the OpenStack API URL. And then I have another example, this time with Proxmox. This is what I used for putting up stuff on our CCDC Proxmox. Basically, again, if you see up top in the provider, very similar to what I just showed in OpenStack, the Proxmox provider expects something called an endpoint API token, right? So then what I do there is I go in into our Proxmox and I get the API URL, and then I get the token, which like is for authentication into our Proxmox virtual environment. So after that, the locals are the host that I'm defining that I want to make with Terraform. The name is literally the name of the VM that I'm making. And then ISO, again, it's a variable. So you won't see it on this part of the file. It's going to be in a different file where I defined variables. And I said that, like, I named the variable server 2022 ISO, right? This is kind of like programming for variables. You can name them what you want, and then you give them a value somewhere else. So in that variables file, I made the value the actual name of the ISO, which was much longer. And this way I could just type out the variable and define it that way. So most of them were Windows Server 2022, and then there's one Windows 10 in there. I named it as a variable Windows 10 ISO. What it actually does is it points to what that image is called in Proxmox. And then I define other things for it, like memory, CPU, things like that, just for the instance to be created. And then, again, there's the resource underneath, which actually goes in, it iterates over those locals, and it creates them with the name, like with all those variables that I gave it up there. It creates that instance. And then I define other things just to make it work. Yeah, oh, okay. This is left over from a different time that this presentation was given, but apparently there's a Discord provider for Terraform. I've never used it, never tried it, but apparently you can create Discord servers using Terraform, which is kind of cool. Let me know if you give it a try. I might do it, but didn't really get around to it. So that's cool. There's, again, there's the Domino's thing, there's Discord, there's Terraform, there are official providers, and there's also community ones. So it's really like, if you figure out how to do this, you can make your own Terraform provider and just like put it on there and create Discord servers and order Domino's. Let's talk about Ansible. So, Ansible is great. Ansible is another code tool for infrastructure as code. It really goes hand in hand with Terraform for our competitions. What this means is like I was describing Terraform, you just created all those VMs, but they're literally just VMs. Like, you haven't done anything to them yet. Ansible, it goes in and it like sets up a base Ubuntu VM, for example. It adds some users. It like uses Apache hosting WordPress with MariaDB, whatever you want. You can do a lot of things with Ansible. And I guess you could call it a Lego-like configuration, because the way that it works is there's an overarching playbook. Then the playbook has different roles, and then each role has a task. So this allows for like a lot of abstraction, because Ansible is meant to be self-documenting in nature. So if I have a playbook that literally is called like setup VM, right? That's like the overarching thing that I'm doing to it. Then there would be roles. These roles would like include things like add users. That would be a role. Then within the role, there would be a task to add user 1, add user 2, add user 3. And then when you run Ansible, you'll basically see all of those things appearing, and you'll know exactly where you are in the playbook. So it helps when you want to like run specific things. For example, you can separate out all of these roles to have tags, and then again, I'm gonna lean on competition as an example. In IRSec, we run Ansible on both the Windows black team and the Linux black team. I said Windows Linux, right? Yeah. So Linux would have a tag that says like Linux, and then Windows would have a tag that says Windows. So when they run the playbook, they're not running the whole playbook. They're running parts of it that apply to Linux if they want to do Linux stuff, and they run parts of it for Windows. So it is very much like flexible to your needs, and you can have everything in one playbook and then separate them out based on what you want. Another cool thing about Ansible is that it is agentless. So that means that you're not actually, like, you don't have to have anything installed on the hosts that you're managing with Ansible. All you need to do is install Ansible on, like, your one machine. So if I want to run Ansible from my laptop, that's all I need to do is install Ansible on this laptop. And then, whatever dependencies, like, I'd probably create a virtual environment in Python, things like that. But Ansible is on my laptop, and then what it does, it connects out to, like, someone else's, I'm not going to say someone else's laptop, to like the VMs I have in OpenStack, right? Those VMs, as long as I create those VMs with a cloud in it that has like one user at least, and I have the credentials to that user because I set it, in Ansible, I'm going to say Ansible, use SSH, and here's the username, here's the password, or here's the private key. Go in and configure this on the host, on the VM. So it uses, again, not necessarily SSH. If it's a Windows machine, it does not use SSH. It uses probably WinRM or PSRP. I'm going to talk about this a little bit later. I'm using this slide for a lot of information. But those, like, my laptop in this example is the control node. And then those VMs out there on my OpenStack are the managed nodes. And they do not have anything on them that makes them, like, Ansible compatible. They're just VMs. All I need is Ansible on my host. And in terms of SSH, SSH or Ansible often uses SSH agents, which means that it saves all of like the necessary details in that SSH connection. Because if you're me and you're running Ansible and it suddenly fails, or not fails, it hangs forever, it's probably waiting for your passkey to your SSH key because you didn't use SSH agents. So don't let Ansible pull your private key that has a password on it. the way that Ansible knows where to run these things, your playbooks on, is using an Ansible inventory. So by default, Ansible has 2 categories, all and ungrouped, and then you can create your own groups for inventory. So the way that it looks is you'll have like your main.yaml. Ansible uses YAML, by the way. You'll have your main.yaml playbook, whatever. Then you'll have your inventory file. It will probably be called inventory.yaml or inventory.ini, which are 2 different formats. Yeah, I have 2 examples here. So, low-key, I need the other slide, though. What the inventory does is you list out all the hosts that you want to run the Ansible on. So this can be IPs, or it can be, I would not recommend leaning on DNS to run Ansible, but it can be host names. And then you can categorize them. So in our giant black team inventory, we'll have like all the hosts listed out, right? That applies to all. Then each host will go as a child of either Linux or Windows or maybe router, whatever it is, because they obviously differ and you don't want to run Linux stuff on Windows VMs. So inventory helps you separate those out. And when you run an Ansible command, when you run Ansible playbook, you'll specify tac I and then the inventory file. And then you can even limit it to certain hosts in the inventory. As long as you create a good inventory file, you'll have a great time running Ansible. And then in terms of inventory as well, there will be variables that you can apply to those groups that you defined. So there can be in-group vars. I would probably have like Linux variables, Linux-specific variables, because I want to say Linux connect with this type of connection, which is SSH, and then Linux connect with maybe this certain private key on this host. For Windows, Windows has a lot of variables. Again, I'm not as familiar with Windows, but you'll have differing things for those different groups. YAML, that's the one I'm more familiar with. I almost never use any type of inventories, but this is how they look. So in any inventory, you will have like brackets defining those groups. So in here, again, like I was saying, Windows and Linux are different types of groups in the inventory. And then you can also have web servers as like kind of like all web servers. And then this is mirrored on the right, but in a different format. So like I was saying, all means that everything, like if you run inventory with no restrictions, it will run it on all of those hosts. If you want to just run on Windows, Linux is a child of the hosts, or all. So it's just like different ways to define it. And then you can define variables inside of inventory, or you can define variables in its own variables file. It's very modular, and that kind of confused me in the beginning because I couldn't find a good example of like what a Linux playbook should, Ansible playbook should look like, because you really can mix and match the different methods. So for example, like I don't know where to put my variables, might as well separate it out. There's something called Ansible Galaxy that helps you set up those Ansible like structures for the files. And that was really useful because like, yeah, it gives you too much at times. Like it gives you group vars every single time. But it is really useful in setting up the structure so that you just have like a working Ansible playbook, and then you can change it however you want. So Ansible Galaxy, search it up. Useful inventory. I decided to add this because, again, usually you want to configure Ansible a little bit. And in the inventory file, the most important things are that you can make sure that you can connect to your managed hosts, right? The ones that you're running the Ansible on. So Ansible host, port, user, password are super important because you want to give it the correct username, password, SSH key, whatever, and type of connection. So like Ansible connection, SSH, or maybe WinRM or PSRP. I already went over this. To tell Ansible what to use. Otherwise, you will literally not be able to connect in. You won't be able to run your Ansible at all. Become and Ansible become method mean that, or end user, whatever, anything that says become means that it's escalating its privileges, right? Elevating its privileges. So in Linux, it would be the different methods are like su or sudo or whatever. Windows, it would be run as usually. And then sometimes you have different users that you want to become as, right? You have multiple administrative users, so you can specify which one to use. Maybe not specifically root. Maybe you have a different user that you want to use. And then on the right are also really useful ones. Ansible gather facts. I don't know why I'm going out of order, but Ansible gather facts is a useful one. It's a true or false one, so only 2 options. The default is true. So if you sometimes have Ansible tasks that don't need to gather facts, and gather facts is collecting information on the system that you're about to run that on. So if you want it to be like, if you want it to run a little faster and you don't need specific things like gather facts usually gathers like the operating system, right? In Linux, if you just cat etc os release, that's where it gets that information. You can tell it, no, I don't want you to gather facts, just run what I tell you. As long as it's not reliant on something where it needs to gather facts from, it runs your Ansible faster, which is cool. Python interpreter, that's a tricky one because it will complain about finding like a mismatched Python version on hosts, so that's a useful one. Common args for SSH, super useful as well. My favorite one there is TAC-O, strict host key checking equals no, because Ansible will yell at you that it, it's like the whole like, oh, you might be man in the middle because the fingerprint changed on the host, especially if you're redeploying hosts a lot for competitions. And then private key file, you want to specify the like path to the key file that you want to use. Because if you have like multiple private keys on your host, you don't want it to default to the wrong one. Tasks. Okay, so again, let's remember, Ansible has playbooks. Inside of playbooks are roles, and inside of roles are tasks. Tasks are, again, that single action. Add user XYZ. That's what a task is. And tasks use something called modules. So I just listed like some random modules there. Package is a good one, and you'll see an example in a couple slides about packages, because there's two different types of like modules. You know how I was talking about Terraform providers? This is sort of the same thing where there are built-in modules. So if it says ansible.builtin.package, or sometimes you can just say package without the ansible.builtin, that means that this is like a native Ansible thing. Or if it's from somewhere else, if it's like a community thing, it could say the thing underneath with the authorized key. That's not a built-in Ansible thing, so you have to define ansible.post. I don't actually know how to pronounce that. Define that whole string. So with the module, each module, same thing with Ansible, they have great documentation, so you can go and look up different Ansible modules. For example, look up Ansible built-in package, and you will have, they basically just scroll all the way down, ignore everything on the page, scroll all the way down, and you will see examples of using that module in a task. So modules basically allow you to abstract what the thing is. So if I'm running a command and it's like sudo apt install xyz package, all you have to do is say package, then you say the name of the package that you're installing, and then present like true. So literally, anyone can read this. They don't even need to understand the command line. They can just see that the package will be installed and the name of the package. I'm going to show it really quickly. So this is another built-in module. This is the user module. So the name, the first line there, is the name of the task. Oh, there's comments. This is great. The name of the task is to create admin users. It uses the module called user, and the user module, it asks for some things. So some things are required, some things are default, so you don't have to specify them. But at least you need to tell them what name you want for the user, right? And what password you want to set for the user. So in the user module, you'll say name, password, and then usually what group you want to add it to, what shell you want the user to use, and then yes or no if you want to create a home directory for that user. So this is obviously Linux, by the way. And then, like I did not get to on the last slide, their tasks can be run conditionally or in loops. So conditionally means like you'll have a task, and then at the end of it, you'll have something that says when, colon. And then, for example, the one that I use a lot is if the Ansible operating system is Red Hat, or if it's Debian, or if it's Ubuntu. That means that it gathered the facts, right? I was talking about gather facts. It takes the operating system, and then it stores it in that Ansible run. So then it can understand when or not to run a task. If I have a specific task that works on Ubuntu, but not FreeBSD, because those differ quite a bit, I can have a task that says when the operating system is Ubuntu. That's really useful. Or when you have some sort of variable to see if something was installed already, something like that. And then the loops for tasks, you use either like with items or loop. So in this example, I believe it uses with items. I think that's older. I think at this point you should be using loop, but I'm not too sure. I think either one will work really. And what this does is it loops over this user's like list, which is somewhere else. It's not in the screenshot. But you can also define it just like if you make a new line under with items, and then you have a bunch of like tags like under name, you can just like define the names of the users that you want to loop over. And then the when right here, item.admin means this was a variable defined somewhere else and is checking if it's defined or not. And then if it's not, or sorry, if it is, then you create those users that you loop over. Yeah. Roles. I don't know why we're going in this order, but remember, playbooks, roles, tasks. Roles group the tasks into a larger action. So, for example, installing Nginx could be a role, and then there are multiple steps that go into that, multiple commands you would have to run. So those would be individual tasks. And then roles, they are better because sometimes you'll want to use like a variable in a bunch of different tasks. For example, like, I don't know, that if you want a name for something and you want to have it throughout those tasks, you'll have it defined under the role. And then handlers, I haven't used those in a while, but those are also really useful. It is sort of like calling a function in a programming language, but do not think of Ansible as a programming language because you will like go down the wrong path doing like writing Ansible playbooks. Ansible is not a programming language, and don't try to treat it as such because it's not as easy as like defining variables and functions and stuff like that. It's more about the flow of what a playbook does. So but having said that, handlers are similar to functions where you can call back to a handler and say like if it's a repeated task, kind of like what functions are for in programming, you have a handler for that in Ansible. Yeah, this is, I can't really see that well. This is a bunch of roles in a directory. So essentially, this is kind of like the most that you could ever include in an Ansible role. I don't use many of these. I never not never. I don't use variables that often in my separate file. I've never used library, meta, module utils, or lookup plugins, but templates are super useful. J2 means it's a Jinja2 template, and that helps if you're like replacing a file or editing a file and you want it to be according to a certain template. You can search up Ansible Jinja, Jinja2 templates. Same thing with files. So this files directory, you have to be very careful with the Ansible files module because a lot of times, like my Ansible playbooks, I'll want to like replace a file on a remote system, and I'll accidentally like move a file from my system to that one, which is not what I meant to do. You want to move the files from like right here in your files directory. If I want to move like bar.txt to like /home/Leah, then that would be like an Ansible task. Defaults are default variables. Variables are variables. Handlers, again, they can be defined in a separate file. I've never done that. I've just defined them in the same file as the playbook or like the role or the task. And then usually if you have a lot of tasks, you will separate them out into a tasks directory and have tasks like named different things. Like it wouldn't be named main.yaml. Usually it would be named something descriptive like Linux deploy OpenVPN server, something like that. Or actually down there, Linux create users. And then we've gotten to the top level, an Ansible playbook. So this is when you have all your tasks, you have your tasks inside of your roles. Now you want to run that Ansible. What you're going to do is you're going to run the command ansible-playbook, and then you're going to specify your inventory file. It doesn't really matter what order you do these things in. TACI, inventory.yaml, and then you'll put the name of your playbook. So like when I do infra, I run the Ansible playbook that's called management.yaml. And what this does is it refers to all those roles. It refers to all the roles that have to do with like whatever I have to do for the management Ansible. If it's Linux, if it's the Linux Black team running Ansible, they're going to run linux.yaml, which is what we name it. It's very self-descriptive. And then what I was talking about with the grouping and the inventory file, if you remember, I'm not going to go all the way back to the slide, but if you remember, there was Linux and then there were hosts underneath it. If you want to restrict to those hosts, this is how you would do it. You would specify TAC-L for limit, and then you would say Linux. And then you would, if you want maybe all the Linux web servers, you would do Linux and web servers. Make sure to escape this with a backslash if you're using Linux or Linux adjacent command line, because and the exclamation point or bang are actual things in the command line. So if I was actually running this in my command line, I would do, for the Linux not web servers, I would do Linux : /bang web servers. These are really useful, again, because it's very modular, it's very Lego-like. You can say whatever you want, whatever group you define, you can run it at whatever time you want. And then this is an example of the top level playbook. So when I was describing, when I like made that off the dome, create users is an overall playbook. And then when it says host all, it's going to create those on all of the hosts defined in the inventory file. Then it's going to call the role Linux create users. So this is somewhere else. This is in the roles directory, and it's called Linux create users. And within that, it will have tasks, right? Same thing here with the install web server. It's going to run only on the hosts that are defined under web server and inventory. And then for the roles, it will deploy Nginx, and then it will deploy the actual website. Whatever that means, whatever tasks are inside of those roles, that's what goes under the install web server playbook. Variables, okay. I feel like I talked about this already. So I have not mentioned magic variables. These are variables that are set automatically. Again, the Ansible documentation is really, really good at explaining these things. There's just a lot of like, the big hump to get over is the different names for things. Like, as long as you remember playbook, role, task, then you can start maybe at the top, learn about playbooks, then keep moving on to like understand what goes into them, how to write a task, etc. It's all there. It's just like a lot, and it's kind of annoying because what like playbooks, roles, tasks, variables are all very specific things. If they don't fit in well, you won't have a working playbook, which is very frustrating. But I already explained playbooks. Group vars are variables for groups. This is like too much. Just like use variables for now. And then the inventory file, I've kind of gone through. I don't know why the slide is repeating itself. I kind of reused some slides. Ansible config. This is a good one. So you will have something called the Ansible config file, and it is named ansible.cfg. So on the left, I added something to talk about like what order of precedence Ansible takes when it uses those configuration settings. So first of all, before anything, when you run that Ansible command I was talking about, Ansible playbook, you can specify things at the command line while you run it, and it will ignore everything else in your Ansible files, and it will use that. I don't use that often because the whole point is that you're putting it in files, so you don't have to type out a giant command every time. The next thing it uses is the environment variable if you set it. So like when you in your command line, you say Ansible config equals, it will go and it will listen to that as the first thing. That's the first thing it checks. That's what it takes. I don't use this one often either. Then it will check the ansible.cfg file in your current directory. So when you're running Ansible, usually you want to just have a directory called Ansible and have all your files in there. That's where you would have your ansible.cfg file located at. That's what I use usually, and that's where you have, it's literally just like a blank file. You don't have to do anything crazy with it. All you do is write out, for example, like host key checking equals no, or whatever. Or forks equals 15. That's a super useful one. I'll get there. Then the next thing it checks is the Ansible config if it's in your home directory. And then finally, etc Ansible config. Basically, like these are just different locations you could have the Ansible config at. This could be really useful if, I don't know, you want to store different configurations and have really specific instances where you run them. Honestly, just use the Ansible config in your current directory. That's the one that it will default to, because you're not really going to set an environment variable. You're not really going to set a command line argument. So number 2 is the way to go. And then on the right, I wanted to include these because I was looking up, while I was making this presentation, I was looking up other Ansible configs because mine's usually not, like I don't have that many things in it. I'll have like forks, and I'll have things to optimize running Ansible. Forks means like, if you've been taking GSys, maybe you learned it in GSys. This is just like how many forks it creates to run Ansible faster. And then timeout would be usually for the SSH. If the SSH connection times out, tell it like, after 1,200 seconds, oh my god. After 1,200 seconds, just give up because you don't want to hang forever. Host key checking, I mentioned that as an SSH argument. You can also define it in the config. Super useful so that it doesn't yell at you for man in the middling when you're not. And then a bunch of the cow things is what I found when I was looking this up. When I first started doing infra, I had no idea what Ansible was. I had no idea what Terraform was. I was learning everything from scratch. And the way that I remembered was Ansible was the one where the cow says the rules, and Terraform is not. Cow say is not an Ansible specific thing, but there are configurations that you can set. And then you can have a cow, or you can have other animals. If you set the I think the accept list, you can have different animals telling you things as your Ansible playbook runs, which is kind of cool. I will be using that. I think you need a little bit of fun and whimsy in your Ansible. So those are cool things to set in your Ansible config so that it runs with cowsay every single time. Or again, you can just run cowsay in the command line when you run your Ansible playbook. That's another option. And I don't know why I have another example, but there's another example of the overarching playbook. The playbook is called install Apache web server, right? Hosts all, again, it means all the hosts in the inventory file it's going to run on. It has become in here, which is useful. Become true, right? It's going to be true or false. It's going to try to run as the root user to do this because you need sudo to run sudo apt install, right? Because, foreshadowing, the tasks under this playbook are update apt Apache. Nope. Update apt cache. And then the equivalent of that little task on lines 6 through 8 is, what is it? Let me see. Sudo apt update, right? That's what you do before you upgrade or install things. So you're going to run sudo apt update. Then the install Apache 2 thing, all it does is it uses, when you see apt on line 11, for example, that is the Terraform, nope, not Terraform, Ansible module. So the apt module, all it asks for is the name, and then state present means install it, you want it to be there. I think the opposite of present is absent in Ansible, I'm not sure. Because I always just install things, I don't remove things. And the equivalent of the install Apache 2 task is sudo apt install Apache 2. And then the final one, ansible.builtin.systemd. This could also be on line 16. It could also just be systemd because Ansible built-in tells you that this is a built-in Ansible module. And what this does is it does systemctl enable Apache 2. Not enable, yeah, I'm lying. Systemctl start Apache 2. Personally, to this playbook, I would add enable Apache 2, right? Yo, I lied again. It actually starts and enables it. I give up, I'm tired. Any questions? No questions. Okay, I better see you all do the demo because I heard that it was using Terraform and Ansible to set up a, I don't know, instance or web server, so you can ask me questions about it. But yeah, have fun with the demo. Please sign up for Black Team. I hope you had fun.